formula n lambda is d sine theta. Okay, so n lambda is d sine theta. Okay, right. The only derivation in this section. Okay, so let's have a look. Step one, we draw it. Okay, and the drawing is absolutely crucial here. Okay, so we draw. We've two slits. Okay, two slits away from each other like that. Okay, and the distance between the two slits we know is d. The distance between the two slits is d. Okay, we know that d, distance between the two slits. We draw the straight through, okay, to the screen, and then we draw two rays that are going to meet to form a crest. Now, there's a slight simplification, but we accept it, it's totally acceptable. The screen is far, far away, okay? The rays are going to meet at the screen. They are going to be almost parallel, okay, to meet at the screen. They won't be exactly parallel, but they will be almost parallel. So these two rays are going to meet at the screen to form constructive interference, and that's crucial, okay? But in getting there, okay, think about it. If there's a crest here and a crest here, at the end we want two crests to get constructive interference. Okay, we want two crests to get constructive interference. So we want, but the path this will take will be a little bit longer. That's going to be a bit further away from the screen. We can find the path by dropping a perpendicular from here to here. Okay, drop a perpendicular from there to there. That's the extra path. That's the path difference. Okay, we mark this angle. We mark that angle as theta. That's the angle where the constructive interference takes place. The path difference, if we want to crest here and we want to crest here. We want a crest to finish here and here, so therefore we want a crest here and a crest here. So there must be a crest at this point and there must be a crest at that point. Okay? So I'm going to call that n lambda, because that will either have to be one wavelength, or two wavelengths, or three wavelengths, or four wavelengths, or n wavelengths. Okay, that must be a whole number of wavelengths for the crests to meet again. Okay, crest here, crest at the screen, crest here, crest at the screen because it's the same distance. This extra little bit has to be either one or two or three or four wavelengths, otherwise you won't have a crest meeting a crest. Okay, that's the crucial point. If you get that, you're sorted. Okay, we're pretty much sorted. Because what we do then is we look, bit of geometry. That's theta, so therefore if you think that's theta, that angle plus that angle is 90. This angle plus this angle is 90, so this must also be theta. Simple geometry there, make sure you're comfortable with that. Okay? The derivation is almost done. The derivation is almost done when you got to that stage, okay? Because our next step is just SOHCAHTOA and sine, obviously, because it's sine here. So what should we do? We say the sine of the angle is the opposite, which is n lambda over the hypotenuse, which is d. Okay. And then we just rearrange and we're done. The big work on this is the diagram, okay, and understanding the diagram. Make sure you understand the diagram, and it's a bit like a Doppler effect then. You practice drawing a diagram, do the extra little bit, no bother, and you have the box ticked. You can derive this one. Check in the notes as well if you need to. All right, very good.